Good morning, everybody, and welcome to the Rundown, second edition of our Academia Meets Manufacturing Summer Series. Alan, how are you today?
I'm doing all right. I ended up watching a documentary on marijuana last night.
Oh, geez.
Turns out it's the best way to watch a documentary.
Thank you, Alan. The dad jokes, we did, I think Alan felt a little slighted last time that we didn't do that many dad jokes. And
that's okay. I wanted to get it in at the beginning, just right there.
Yeah, no, that was a good one. Alan, we've got some familiar faces from last week, and we've got some new faces as well. Let's just go around the horn real quick. I'm going to go to Alan's left. If you remember Michael from Deloitte Smart Factory lead from last week. Michael's been working with Pierre over at Wichita State University. Pierre, I freaked out after our meeting last week because I kept using the term aeronautical engineering. And then I started thinking, oh, wait, should I have been using aerospace engineering? So help me feel better. Is it more of an aerospace or aeronautical program at Wichita?
You can feel worse.
It's aerospace, but they're close. They're similar. No worries.
Well, I now know the definition and the difference. So, right, aerospace is if we go outside of the atmosphere, right? And aeronautical is when we stay inside. So aerospace. There we go. Didn't mean to slight the program that way. Sorry.
Oh, no worries.
And we've got Sherry. Hey, Sherry, how's things in New Kensington today?
A little steamy, but good. It's kind of warm here.
Yeah. Well, I'm glad that that's not the case for Alex today. Alex is joining us from Sheffield, where they've been going through record temperatures, but they have subsided, right, Alex?
Yeah, we can breathe now. Which, we're not prepared for it in the UK. We don't have aircon, so when it hits 106, 107 degrees, we just cease to function.
Hey, if it makes you feel any better, I was speaking to my partner Graham, who's down in Johannesburg, South Africa, and he's moving to the States. And he said, "Hey, do most homes in the States have air conditioning?" And I said, "Well, yeah. I mean, of course they do." He said, "Yeah, because we don't have air conditioning anywhere. It seems like in Johannesburg." So, Alex, it could be worse. It could be worse. Of course, they didn't build homes, for the cool weather of England either. So
we get both sides of the coin. Right?
That's right.
Mostly the cold side, but.
And then from the boardroom, live from Fayetteville, Arkansas, we have got Chris and the INCREP team. Chris, you want to introduce who you've got beside you?
Oh, yeah. So we have some of our research experience for undergraduate students with this. They're going to be giving a live demo here in a moment. So everything's going to go wrong. So please be patient. But we have Gideon. Actually, do you all want to introduce yourselves real quick? Just your names and stuff?
Sure, I'm Gideon. Nice to meet you all.
And what are you majoring in and what year are you?
I'm majoring in computer science, and I will be a senior this year at the U of A.
Awesome.
I'm Robert McClendon. I'm studying computer engineering, and I actually just finished my undergraduate. So starting next semester, I'll be starting graduate school here at the university.
Nice to meet you.
Sorry. I'm Jeremiah. I'm a biomedical engineering major, and I'm going to be a senior this upcoming year.
Awesome.
So are all three of you currently looking for jobs? Internships, positions?
I will be looking for an internship next summer, I believe.
Okay. All right. Well, we'll make sure that we know how to get you connected to the community if anybody's looking for rising talent to their organization. Hey, I did have a question for the group, just a collective, as we get started. How many Germans does it take to screw on a light bulb?
It's a brave question.
That's a good.
I think it's 9. Just
9?
9? No, it's not 9. But good guess. Good guess. It's actually 1. They're very efficient and not really funny. All right. U of A, INCREP team. Let's talk real quick. Let's do a review. Chris, what is the INCREP program that University of Arkansas is a part of, and how does it benefit utilities or manufacturers? What's the link between academia and industry.
I'll give a real quick overview, and if people have questions, please feel free to shoot me an email, and I can give you a more in-depth answer. But basically, NCREP is the National Center for Reliable Electric Power Transmission. It's a big research lab, a 6 MVA, 6 megawatt power electronics research lab that we have here at the University of Arkansas. And it came about as a direct response to the 2003 Northeastern blackout, where you had the entire northeastern part of the United States, along with a large swath of Canada, lose power for around 18 hours due to poor communications and poor planning and, right-of-ways underneath the power transmission lines not being cleared. And people started saying, wow, how can we start making our grid more reliable with power electronics and monitoring systems? And so that's kind of how we came about. And then as we've been doing power electronics with distributed energy resources like solar inverters, battery energy storage, things of that nature, we also started working on traction drives for electric vehicles like electric airplanes, electric cars, electric trains. We actually are working on a project with Caterpillar on the DE7, the big earth mover, because they have a hybrid earth mover now because it's more efficient to use. And then we also do a lot of work with cybersecurity and industrial control systems. So that's kind of the 30,000 foot view. But basically our lab, we have other undergraduate labs and graduate labs. And whenever they're doing research and projects at like the 5 kilowatt level, that's fine to do in those labs. But then whenever they want to come over and work in the hundreds of kilowatts or megawatt level, they come over to NCREP. We have basically a substation here where we can do a lot of high power testing and such.
Okay, very cool. And so what, from the student team, Jeremiah, Robert, Gideon, what are we going to see today? Do you want to go ahead and prep your presentation and we'll get it on the screen?
Yeah, sure. Yeah, so we'll be simulating essentially the Ukraine 2015 attack that occurred on some of the ICS stuff there. And then if you want to give some background onto what that was.
So our demo is we're going to be highlighting some of the vulnerabilities of the modern grid. As the grid has become a lot more digital compared to analog in the past, it's increased efficiency and stability of the grid, but at the same time, it's increased a lot of the cybersecurity risks that the grid has. And one big example of that is the 2015 Ukraine attack, not the 2016 one. We're talking about the 2015 one this time, in which December of 2015, 200,000 Ukrainian citizens had power shut off to them for several hours. In this, there were 3 parties, I will describe them as, that were involved. There were the SCADA, which is the people sitting at the power stations are in charge of the grid. And then you have the substations where the power is actually routed to, who the people are trying to communicate with. And then we have the attackers, the hackers. So this is where I'm going to hand it off to Gideon. He's going to talk a little bit about topology.
Yeah, so to simulate each of those previously mentioned parties, we created a bunch of different virtual machines to serve as like simulations for those parties. As we can see, here's the topology here. We have these 2 machines we use just for testing for earlier labs, this Windows and Ubuntu machine. But the 3 machines you want to pay attention to are this Kali Linux machine, this Ignition machine, and this Typhoon Hill machine. The Kali Linux machine will serve as our attacking interface. The Ignition serves as our SCADA. And then the Typhoon Hill, or hardware in the loop, serves as our simulation of the grid itself. And then we will go through each of these one by one before performing the attack itself. So,
okay, so you're going to simulate the attack, and yes. The goal is what? Obviously to try to prevent the outcome, or to get better information around the attack?
I think both as a whole, just to be able to like simulate it, to be able to like recreate if we're able to recreate what has happened, then we can take better steps in like processing like the individual steps and then develop mitigation for those things.
Awesome. Okay. You've got Alan's attention already because you're talking about cybersecurity. So this is where Alan wakes up and starts dreaming up ideas and future questions he's going to try to stump you with.
Awesome. Why are you talking, Jeff? Let them continue.
This doesn't count against their 10 minutes. Just so everybody
All right. So what I have pulled up in front of you guys right now is the grid that we are simulating. This is representative of the Ukraine. If any of you recognize this in part, this is the IEEE 4 bus system, to which I have added a couple distributed energy resources. I added a battery inverter as well as a diesel generator. And we also have a Modbus port to connect our simulated grid to what Robert will have control of is his ignition software. So this is where I hand it off to him. Right.
Yeah, so like Jeremiah mentioned, he was working on the grid design side of things, and I was mostly responsible for developing the human-machine interface, HMI, using Inductive Automation's ignition software, to be able to allow Gideon, the attacker, to essentially read the values generated by the control system or SCADA. So this is what we're looking at currently. We have the layout of the IEEE 4 bus system and then the different voltage and current values. And then over here on the left, I've included different tabs to view different things and on and off switches for the diesel generator and the battery inverter. Let me go ahead and turn those off.
Real quick, the diesel generator and the battery inverter. A bit more background about the Ukraine attack, what actually happened. So the attackers got access to the operational technology side of the system by using a Windows exploit with Microsoft Word to get into the IT side, which they wormed into the OT side after that. And then through that, they had direct remote access, and they just turned off several substations around the country of Ukraine. And then they stopped the people working at the facilities from being able to remotely turn them back on. So they had to go and turn all of the breakers back on manually, which took several hours. So for us, we don't have substations per se, but these distributed energy resources that we have, the diesel generator and the battery inverter, those are going to be what are representative of the substations being turned on and off.
So just to be clear, the attack, the surface attacks area is Microsoft Word that was installed in the IT domain, but then was connected to the OT domain.
Okay, I can get into that more if you want me to. I like this stuff. So they used spear phishing. They sent out emails with the Microsoft Word link on it.
Yep.
And then through that, there was an exploit. I'm not sure about the exploit too much, but I know that there was an exploit with Word, which would allow you to get into the system. Once they were in the IT side of the system, they spent months there without doing much, just watching, waiting. And through that, they got access to the VPNs of some of the workers who remotely accessed the OT side. And by getting those VPNs, they were able to access the OT side, the SCADA side, and actually have access to the power system and not just the information technology.
Got it. Thank you.
And so from the ignition side of things, it primarily focuses on detection of any errors that might be occurring. So what I've done here is I've added an alarms table. So if any of these values were to change drastically, like I know in the Ukraine attack, everything was internal mostly, right? Like external, like yeah. But if someone, like say an operator of one of the substations was to plug a like dirty USB in somewhere and then values were to randomly start changing, alarms like these in ignition would be able to catch that kind of thing. And so that and the data historian was also used. So I don't have it shown, but each of these values are being logged every so often. So if there were to be an attack of some sort, and people were to try to find like when the attack started, they'd be able to go through that log data, find out when that actually occurred. Gideon, do you want to take over?
Yeah. So now that we have the two, like the observer party and the victim party described, now we can begin to perform our attack. So I'm going to log in. For those of you who aren't familiar with what Kali Linux is, it is a distribution of Linux, but loaded with pretty much every commercially available hacking tool possible I can think of that's open source, so which makes it an incredible just testing resource when it comes to cybersecurity. And what we've done is we've developed this Python script, which allows us to demonstrate a couple different attacks. So I'm going to be doing three. One, I'm going to be writing to the coils, which is like serving as a replay attack of sort. I'm going to be using a spoofing attack to trick the SCADA into seeing different values, and then I'll be just performing outright denial of service. So first we have to create a man-in-the-middle attack, which is essentially what we're doing is right now the SCADA and the Hill are communicating between each other using Modbus TCP, which is like it's a protocol. And so what we need to do is to trick the two devices into sending the traffic through us instead of directly to one another, which can be used. We can use this tool called EtherCap. I've already scripted it to enable automatically, but what this does essentially is now the traffic is flowing through our device instead of directly between the two, which allows us to do some crazy stuff. So first we can see the generators are on. I can now directly from the attacker machine and then inputting some data. This is already some preset stuff. So there's 2 coils. I'm going to turn both coils off, and then I send the command. It takes a second to load up the console. And then also this attack is showing the post-exploitation portion of the attack. So not gaining access via the Word document. This is to show what would happen after they were waiting inside the machine and then they decided to act. So as we can see, it sent the values. As we can see over here, we've now turned the generators off. Now I'm going to spoof the data. So exit out of here. As we can see, all the dials are showing data, fluctuating. These over here are showing data. I'm just going to make it not be able to see anything, which is not what they did, but it shows the proof of concept.
Mm-hmm. While you're doing that, can we just do a disclaimer real quick?
Sure.
Ignition was not involved in any of these attacks in the Ukraine, correct? And what we're demonstrating right now is not a vulnerability of ignition. We're simply using ignition to demonstrate the principle, correct?
Yes. Okay. Yeah. This, as we can see right here, it's a Modbus TCP script. So what this does is it's basically like injecting data or manipulating the Modbus TCP stream. So in theory, this can work with any, like not the Typhoon, it can work with any other Modbus device or with any other SCADA. So I'm going to do a denial of service real quick.
And while you're doing that, the point here is that you're actually coming in between the communication from the HMI to the PLC in the middle, and then you're now allowing or making all that traffic flow through your system.
Yes.
And so you can control the device while making the system see something completely different, as if it was on still.
Exactly. So kind of behind the scenes, it reverted, but I enabled denial of service. What this attack does is it turns our device into a firewall, which blocks Modbus traffic. So instead of the typical denial of service where you're flooding something with packets, this uses a more restrictive version where it just outright just cuts off the connection.
I think we're about out of time. I don't want to go over because Jeff will get mad at me.
No, go. You're fine. And I'm going to bring Sherry back, and I think Sherry had dropped. And we've got Sherry back. So continue, please. It's fascinating. I think what you've done is great. Let's continue talking about it.
Okay. And I was just going to give them a quick overview because they might not know what Typhoon HIL is. So you might want to talk to them. Okay. Well, so Typhoon HIL, it's a real-time simulator, kind of like Opal RT or some of the other real-time simulators. But basically, you can emulate hardware using these devices and emulate them all in real time. So you can actually emulate entire sections of the grid and attack them without actually attacking any physical systems and such. And then the platform that they're using is this NDG, it's NetLab Plus, and it's the same platform that the CISA training, the 301B, for any of you who have taken that before, it's using that same platform. And they've actually developed pods so you can replicate this on the servers multiple times such that students can come in here and use them. And again, we're not demonstrating any kind of vulnerabilities of any particular software, but more the theoretical, man-in-the-middle attack, arc poisoning, things of that nature, more conceptual ideas. And the reason that this is impactful for our students is we're developing more and more of these, and we have our incoming students come in and say, hey, go through these examples, just like the CISA 301B course, open up Metasploit, go through and see what vulnerabilities are out there. So when you're developing software or you're out in the field doing these things, you know what the best practices are. So just a top level overview there. So sorry, and was there anything else you wanted to add?
I mean, no, that's essentially the attacks. Yep. So yeah, like I said, as we can see, we've restricted. So yeah, basically it just involves, showing what happened on the post exploitation portion and showing off the ability to just manipulate the Modbus TCP data that the services are communicating with.
So can I ask a quick question, Jeff?
Yeah.
So you mentioned about how you got into the OT through the IT pathways, and in manufacturing, we are constantly dealing with the IT-OT interface and combat, often inside of organizations. So just like to talk a little bit about how you, the students, kind of engaged in the understanding and discussions about the IT-OT interface and the importance of the kind of merging of the two organizations, which are often handled separately, because it sounds like that is it's obviously a critical issue for operations, but it's obviously a very critical issue with respect to protection and cybersecurity.
So we have dealt with the IT side a little bit less. The Ukraine attack definitely involved that bridge, but we didn't actually have to deal with it because we just started with the man in the middle already. He didn't have to get in the middle; he was already in the middle. But I'm sure you have a lot to say about that.
Yep. I didn't want to take it away from y'all. But so as you know, we work a lot on this, and some of the things we go and try to implement what the fence in depth. So we have a lot of different layers of authentication, and then whenever we're building up these devices, so even if we basically assume that the attacker is going to penetrate the system whenever we're developing our controls and such for hardware. So like we're developing a solar inverter, for instance, like the one we're building up for our DOE project, a cybersecure solar inverter, we assume that the hackers are going to penetrate our defenses to a certain level, and maybe they're able to even load a malicious firmware onto our device. And so what we do is we go through, and before that firmware is actually activated, we go through and we check it. We check, make sure that the signatures are correct. But then we have a real-time emulator, for instance, implemented in FPGA, and we actually run that firmware and make sure that we're getting signals that make sense for, not to get too far into the weeds of electrical engineering, but we don't want them to, quote unquote, crowbar the supply where you turn on two switches and cause a dead short. So we check for those type of actions before we greenlight it and allow for the hot patch to occur when moving the firmware over. So we do things like that. And then we're also working with some companies on IDS and IPS and mitigating enabling their current IDS systems to be able to understand Modbus traffic, IEC 61850, DNP3, all those more standard control system protocols, such that we can have intrusion detection on an OT side as well. And they can detect things with machine learning. Hey, we're not used to seeing this much traffic to these types of traffic, and they'll identify it and let an operator know that needs to be investigated. So we didn't go too in depth with that with these students because they're only here for the summer. And so 8 weeks flies by quick, especially whenever we're trying to do things like career development and resume workshops and things like that. But very good point that the IT side of things is very important.
Well, the complexity between IT and OT is always the priority, right? I don't know if you can see it on my board behind me, but it has to do with an IT confidentiality is the number one priority, and then integrity, and then you have availability. Where in OT, it's always availability, and then integrity, and then confidentiality. And so as you try to merge those two things together, you're literally trying to figure out how to get people from the IT space to understand when you're in the OT space, you have to change your mindset. And then the OT people, when they're in the IT space, you got to change your mindset. So it's the, hey, if I ever have a situation, don't shut down my process. Let the process continue and then react and try to mitigate the risk. Whereas in IT, the very first thing you do is you shut down the communication. And so it's very complicated to try to merge those. And that's why forever we've had that conversation about, the OT and IT convergence. And a lot of people talk about it. A lot of people try it. Not very many people actually are successful at doing it.
That's one of the things that some of our partners, we have a number of industrial partners that we work with and kind of get an idea for what they want us to do research on. And that was one of the big pushes for us to do digital twin and hot patching, because they wanted to find a way to be able to update their systems out in the field without having downtime. Because right now, if you have to schedule downtime, then that bug or that known vulnerability is going to exist out there in the substations or in the manufacturing plants and all that type of stuff until it gets patched. And so we're trying to develop ways where we can hot patch, where we validate all the firmware and then we switch firmware so that the downtime is on the order of microseconds. So it's basically no downtime is incurred, so they don't have to schedule it.
May I say something? And this is also one of the really cool things about softwares like Typhoon Hill and OpenRT is that because the grid is critical infrastructure, you can't just turn it off. Prototyping, stuff like that is a lot more difficult. Softwares like Typhoon Hill and OpenRT allow you to fully test and simulate all your grid components before you ever actually have to put them in the grid. So you know that they are ready to go once you actually need to implement them.
And none of these are sponsors, by the way. So we're definitely agnostic. We'll use whatever tools and resources we have available to us. So
sure. Well, thank you very much, Jeremiah, Robert, Gideon. Chris, how can someone get in contact with you, learn more about the program, and in turn even get in contact with your students?
Oh yeah, definitely email is usually the easiest way. So I don't know if you want me to pop my email address up there, or I can get a card ready and we can pop it up later on if you want me to.
Yeah, please share it in the chat and as well as just through the Integrate Live LinkedIn page. If you want to reach out to Chris, just ask and we'd love to make that introduction for you. Yeah. Hey, well done. And gentlemen, thank you so much for making time to present that today.
Thank you. Thanks, everyone.
All right, let's kick over Michael, Pierre. Let's talk about Smart Factory, Wichita State. I know there's always NDAs in place, but from the Deloitte side, can we talk about a couple of client wins that you might have experienced already with Smart Factory? It's only been 2 months, but well, heck, I guess a month and a half. How's it working?
Absolutely. And, maybe thanks for the intro earlier. I should mention that before I started working in Smart Factory, I used to work at a calendar factory, but I got fired for taking too many days off.
That is such a coincidence. I worked at a keyboard manufacturer and I missed too many shifts, so they can.
Yeah, I'll get you. Maybe before we dive into some of the client wins, we could pivot just slightly. Building up a little bit what we talked about last week in terms of, we're predicting there's going to be a pretty massive skills gap in the next 5 to 10 years, especially in manufacturing, IT, OT. Maybe like to tee up Pierre to talk a little bit about the applied learning program, because that's going to tie directly into one of the first wins that we'd like to talk about that's going on at the Smart Factory at Wichita.
Awesome. Thanks, Michael. So I mentioned it a bit last week, but just to maybe recap on it, at Wichita State and at the National Institute for Aviation Research, NIAR, we have what we call applied learning. So that's, taking students that are learning in the classroom at a typical, just any typical university does, but we put them into real world experiences, immerse them in the real world problem solving that we're doing in our laboratories, or pair them up with industry partners. And this is more than just a traditional co-op or summer internship. These are, many of these experiences last years. They could start as a freshman or a sophomore even. and work in these companies or work on these projects and learn, how to speak like companies speak, learn how to interact with people. So they get the soft skills that you're not going to get in a classroom. And that becomes very valuable to our industry partners. And then they're also getting the hard skills. We have students in, one of our labs we're taking apart and reverse engineering big airplanes and ground vehicles for the Air Force and for the Army. So these are students that are learning, what a Station 470 bulkhead is on an aircraft. And when they go out in industry and those industry partners, they know how to speak the language already. And so that's a really big deal for our partners. And that's how we address a lot of the skills shortages that we're seeing there is making sure that students are not only learning the fundamentals, the engineering or the business fundamentals, whatever school they're in, but also learning how to interact and work and those soft skills that they get. And our industry partners come back and tell us that, students that go through that applied learning program really spool up and, you can take the training wheels off once they're hired very quickly, within 6 to 9 months, where traditionally, a new hire, it can take up to 2 years till they're fully independent and working on their own. So we find that a very powerful advantage for our industry partners and a unique way to address skills and shortages.
And the reason why I wanted Pierre to bring that up is from an industry perspective, as a company that's hiring a bunch of individuals who come work in Smart Factory, supply chain, strategy, we are becoming less and less interested in universities just pumping out a traditional engineer or somebody maybe coming out with a finance degree or an accounting degree. What I'm very interested in is having students that are entering the workforce that know data science, maybe some industrial engineering, have a base level understanding of accounting and how that's going to impact the bottom line to a business and a client.
Yeah.
And the traditional academic model in the past has been much more siloed. What Wichita State is trying to do with the applied learning is really get a cross-discipline flavor for the students coming out of their program. Recently just offered a full-time offer. Now that we're up and running, we have a mechanism through Wichita State, through the Smart Factory, to begin hiring students directly into our Smart Factory practice, our supply chain practice, and our industrial products practice are like the three big areas. One of the things that we're looking for is students that have real-world experience and can take data, put together an analysis, and then present that using soft skills to clients to make strategic recommendations on what they're going to do. The lady that we just hired, she was an international student from Nigeria, had come over. Her parents encouraged her to try to go become a doctor. She was more interested in taking things apart, learning like the manufacturing and mechanical engineering aspect. She focused on that, did an internship with us, killed it, and now we'll be bringing her on full-time to work with us doing strategy consulting work.
That's exciting. That's really exciting.
If I pivot that same kind of archetype, instead of being personified as a student, think about it being personified as a business offering at Deloitte. We have had a very long and partnering relationship with an airline in aviation. We have traditionally done a lot of strategy work and maybe some more financial type advice work with this individual client. We got them to come and bring their executive leadership team to the Smart Factory. This is before the grand opening, so it was one of the precursors. They walked away from spending time with us in the Smart Factory, actually seeing Industry 4.0 applications, and it changed their entire mindset in terms of what Deloitte is and what Deloitte offers.
Yeah.
That then led to a very senior conversation about what we could help on some of their technical operations and some of their day-to-day operations. Really got our foot in the door, and now we've executed a strategy assessment to help them put together a long-term strategy for how they're going to adopt Smart Factory technologies into their business. So it's already opening up brand new business for us in spaces that we were never playing before, just because we didn't have the mind share that we were hoping to start building today.
Oh, that's fascinating. And I think about, from being on the business development side my whole life, the number of times that I've done a presentation, I've shared information, and mind you, have put a lot of time, effort, and research into communicating clearly and engaging the audience, right? And I'll go over a point, and 30 seconds later, someone asks me a question and says, well, yeah, but do you? And it's the thing that we had just shown on a PowerPoint. Like, yes, we do. In fact, at the end of the day, people, you can tell them 100 times, right, that you do something or you have the capability. But when you bring them and you show them and they interact, all of a sudden it's those aha moments. Yeah, that's incredible that you've already had a win that fast.
So I have a question, Pierre, about the engagement of your students. How has your luck been in getting them engaged, and how do you kind of recruit or make them aware of the opportunities that you're providing?
Yeah, great question, Sherry. So, we started tracking how many students we get engaged in this applied learning about 7 years ago, about the time when we started this innovation campus and started bringing industry partners like Deloitte and the Smart Factory onto campus. We started tracking that, and we've grown substantially in how many students that we engage in that. I think about a year ago, the stats were over 5,000 students. And we're at about 16,000 total at the university. So over 5,000 had some kind of applied learning activity just in our labs that we have between National Institute for Aviation Research and National Institute for Research and Digital Transformation. We have over 800 students engaged just in our labs working. And then we also tracked, these are paid positions. We tell them, we give scholarships when we give applied learning. It's called a JOB, a job. So we started tracking, and last year we paid over $27 million in wages to students. So when you think about that compared to a traditional scholarship academic program, that's a pretty big endowment that you'd have to be putting out $27 million worth of scholarships every year. So over 5,000, like I said, and growing. So when we started, I think tracking this back in 2016, the numbers were probably half of that. And so it's growing substantially. At the same time, we've also started as a university recruiting along the I-35 corridor, which Wichita, Kansas, with I-35 goes down to Dallas and then further south and then up through Kansas City and Chicago. So we recruit all along that I-35 corridor and also along I-70. And any student that lives in counties that surround those major metropolitan areas on I-35 get in-state tuition in Kansas. So same time, 2016 when we started this and started really pushing heavy, we were about 250 students coming along that I-35 corridor, and now we're over 1,200 last year. So it's been a big push and a big success story. Thanks for the question.
A question about soft skills, emotional intelligence. Do you have a program that you're teaching those things to? Is there a process that you're following to teach soft skills and emotional intelligence?
Yeah, so we have a program called the Shocker Career Accelerator. So in there we have things like there's actually, we get donations from clothing companies, and so we have a wardrobe where students can go and pick up a suit for an interview, something like that. And then we also, we teach, I heard the NCREP folks earlier, resumes and how to do that kind of stuff. But they also have classes specific to, how to have a meeting, how to hold an effective meeting. So a lot of those IQ and EQ things, they offer those as part of that Shocker Career Accelerator. We also do things with our industry partners. We have applied learning agreements with, where they'll come to us with, with the problem they need a solution for. So we have a local company actually that we're doing level 1 and level 2 IT support with them. So we have staff members that oversee students, and they're somebody forgets a password or needs a patch on their device, they bring it there. But those companies will come to us with the problem and say, hey, to be able to address this, I need the students to be able to use this particular type of software, or they need these type of skill sets. And part of our partnership agreement with them is that we will train those students. We'll go find students that either have those skills, or we'll find students and train them with those skills and then put them into those engagements with our partners. So we found that to be very effective.
One other part of the ecosystem, one thing that you just reminded me of, Pierre, last year, I brought one of my teams. I think I had about 30 people working for me in Wichita, and we actually partnered with Wichita State. There's a gentleman who's a professor, Joe Graham, who is kind of a world-renowned public speaking coach. We actually paid Wichita State University to bring my professionals to take Dr. Graham's course over the series of 3 weeks, just to continue to build public speaking, EQ,
Right.
and like all that stuff for my staff are skills that I need. And these are people that have already graduated. It just doubles down on how important this is, and having access to academia, again, going back to the bridge between academia and industry, that's another feedback loop that we're trying to take advantage of.
It's fascinating. I have to think that as potential students are touring Penn State, New Kensington, Wichita State, University of Arkansas, University of Sheffield, like the value of that degree becomes amplified and compared to looking at other schools that don't have these relationships, right? If your idea is to get an education so you can land the right connections and the right job and the right network, the way that you're elevating the value of these schools compared to just showing them, well, this is the campus and this is the classroom of the engineering department, right? That's fascinating. Any other wins, Michael, you want to highlight? Anything that you've already seen Deloitte pick up from clients?
I mean, those are two big ones. One of them that I might mention is we have a very important client to us in the aerospace industry who a couple years ago made the decision that they want to be cutting edge in all things smart factory and technology. They have brought us on a few years ago to be their partner to help them build all of their capabilities. Now that we have the smart factory in place, we've got our own cybersecurity, we've got strategy, we've got ITOT. We're building our own internal capability. And so it's almost a little bit of a petri dish to display, test, have some additional R&D, almost like R&D surge capacity for this particular client. But then they can come and bring their team to Wichita State at the Smart Factory, and we can have whiteboarding sessions late at night talking about what is going to be the future of this business and where are they making investments. And we have a 5-year roadmap as to how we're going to take them from today, already doing very cool stuff, to as technology starts to hit the industry and that cost component starts to come down or gets a little more affordable. They want to be the first people through the gate to build a competitive advantage. They really think that by making these investments today, it's going to help them take market share from their competitors in an already very consolidated marketplace.
So I've got a question on so digital transformation, industry 4.0, call it whatever you want, but how are you interweaving cybersecurity into that? Are you following the 62443 standard, the NIST framework, or are you going more towards where I think the industry is going to go personally is in the zero trust kind of path, right? Where we kind of all know we've let the rabbit out of the hat around the Purdue model and the connections and the conduits that we've created between all of our zones, right? And so do you see us moving more towards that, hey, we're gonna stop all privileged access and then validate each individual and application instead of trying to, as a whole, just say, okay, we're going to put the layers of defense in and then hope that everything stays as is?
I'll give you a half answer, Alan, mostly because I'm not the cybersecurity guy. But I think about it kind of maybe two directions. One, even breaking from the IT and cybersecurity for a second, the way that we think about it in general is working with businesses in Smart Factory. Everything is process first. If you don't have a good analog process, you don't have good decision criteria, it doesn't make sense to digitally enable it. You'll just be coming up with a more efficient way to make a bad decision. So start with process, digitally enable it, and then make sure that you've got your cybersecurity protection, that stays protected. Right now, in industry, what we respond to a lot is just regulatory compliance that gets dictated to us. So think CMMC, NIST, FedRAMP. A lot of our clients are looking at like AWS GovCloud, for example, to make sure that there are those protections in place. We spend a lot of time working on single sign-on, working with some sort of like Active Directory. So there is a little bit of, I would say, almost offensive might not be the right word, but like working ahead to prevent some of those, in addition to building in some of those defenses that you were talking about. In terms of the actual mechanics of it, I would have to yield to Pierre because he might actually be closer to that than I am.
Yeah,
No,
I'll drag this into a completely technical talk that nobody wants to hear. So
I wouldn't even be able to participate, so I would have to be listening to you.
Oh, and that's why I'm here, Alan, is to say, hey, let's get back on topic. And to get back on topic, Pierre and Alan, I'll let you take this one offline and you can post your conversation in LinkedIn. Alex, the patient and polite Englishman waiting. Hey, let's shift over to AMRC. Alex, give me a recap in case I forgot, and the rest of the viewers. What is AMRC? What's the mission? And how's it going?
Sure. So the AMRC, we're based over in the UK. We're part of the University of Sheffield. And what we try and do is we try and bridge that gap between academia and industry, right? Which is the theme of these webinars. But typically, what we find is research tends to be, not always, but it tends to be relatively cheap to prove out in a lab environment. But it requires funding and resource, and sometimes prohibitively so, to mature it and de-risk it to a point that is at a sufficient level of maturity to be adopted by industry. So the AMRC, we kind of sit in the middle of that and we bridge the gap. So we're part of the University of Sheffield. We're non-profit, and we're partly government backed, and kind of that's our main aim. Really, have one foot in each camp and try and align the two worlds.
And you've been at it for 20 years.
Yes.
You've seen it. If you recall, for our viewers from last week, they've actually priced themselves. They've revitalized an area in such a way that they've priced themselves out of even being able to buy the land anymore. That used to be free, and now it's like everything else, $500,000 US an acre. But it's been 20 years of track record. How's it going? Let's talk about some of the wins.
Absolutely. So I think we'll kind of divide it into two camps. We'll talk about the kind of economic wins, which is, obviously I'm not an expert in. We've had it. There's recently been an independent review of kind of the catapult centres, which is the kind of the UK framework for these types of research centres in the UK, and more specifically looking at the AMRC in the region around Sheffield and the impact we've had. So I won't kind of bore you with the numbers. You guys can see this is a QR code if you want to read into some more detail, but. We touched briefly last week on the training centre, which is obviously a huge part of these discussions around how do we start to bridge that skills gap. And just quickly to recap, so the AMRC, we have what we call the training centre, and we take in around 250 to 300 young prospective engineers every year. Each one of those is sponsored by one of our partner companies, and that partner company tailors the modules for that student depending on the skills required within their business to a certain degree. They foot the bill for the education, and they can leave the training centre anywhere from kind of bachelor's degree all the way up to a doctorate, and the student is guaranteed a job at the partnering company at the end of that degree. So in terms of kind of economic benefits, so we've had just over 1,700 apprentices go through that system now. And 80% of those were from the local region. So it's really trying to kind of bring manufacturing back to the region and fill that skills gap. In terms of kind of from a monetary sense, I won't list these out, but the kind of headline is for every £1 invested at the AMRC, we've generated around £4.5 into the economy. So we're really proud of that. We've got around 500 active research staff, and I won't repeat what I said last week around the areas we work in. But going back to the images from last week, we kind of started from really humble beginnings. It was almost like a shed in the middle of a field, and now we've got across two sites, and we really feel like we're making a difference.
That's great. I can't believe so the return is a 4.5 to 5 to 1 investment.
Absolutely. It's quite a good segue, actually. If you just flip over to the next, I think it's the next slide. So this is a bit of a technical case study that I'd like to briefly dive into.
Yeah.
So BAE Systems, they're one of the subcontractors to Lockheed Martin, and they manufacture the F-35 Lightning II fighter jet. And part of that contract is to supply 57 different body panels for that aircraft. The panels themselves, with the aircraft being a stealth aircraft, they have to be extremely accurately and repeatably machined and manufactured to keep those stealth properties. And the way that the panels are manufactured at a high level is they're laid up into a very accurate mold. So the outer mold line is very well controlled. The issue that they have is then have to take the panels out of the mold, flip them over, machine the inside face to make sure they fit onto the substructure, and then they drill the holes for the fasteners from the inside of the panel to the outside of the panel, because the inside's the fuel tank, and you don't want burr and things within that fuel tank. So what you have a very accurate panel with holes that have been drilled from the inside to the outside. The next step of that process is to countersink the outside holes. So you basically provide space for that fastener to sit flush within the outside panel. And BAE, so there's roughly 57 different types of panels, they're all quite complex shapes. So BAE estimated that it would be in the region of 75 million British pounds to have the tools required built to be able to do that second half of the process. So they started off quite a while ago between BAE and KUKA UK, the integrator, and they started a project to investigate whether they could prove out that pre-drilled holes, so we'll still drill them on a CNC machine from the inside out, but to see whether we could identify those pre-drilled holes and use an off-the-shelf 6-axis robot like a KUKA or an ABB to do the countersinking action on that panel. The challenge with that was robots off the shelf like this were primarily designed to be used in car plants for spot welding. So they're between 1 and 1.5 millimeters. It's quite a generalization, but not massively accurate and nowhere near as accurate for this kind of application. We're talking kind of half the width of human hair, really tight tolerances. So in order to improve the accuracy of the robot, we can either fundamentally change the robot, improve the stiffness, which is usually prohibitively expensive, or you can better understand the position of the robot. Long story short, you can either use a metrology system, an external metrology system, so you can check the position using a laser tracker, which is susceptible to dust. You need line of sight and a whole other load of constraints and restrictions. Or you can use a local metrology device. So what we used basically a camera system, which finds the pre-drill hole and it aligns and uses some other technology to make sure it's completely normal to the panel. And it countersinks, and then it also inspects that hole as well. So the headline from this was with the development that we did with BAE at the AMRC, that £75 initial estimate of investment required to provide a production line that would meet rate that would give them enough capacity was, so that 75 million was reduced to 5 million after deploying this technology. So on top of that as well, because of the way that we approach this, it saves them around 3 million a year in operating expenses as well. So it's a lot more. We have one manufacturing cell that can manufacture all of the 57 panels rather than physically build fixtures for each. So that's kind of one that we really do like to shout about, and it really kind of shows how the partnership model and the various partners can all come together to produce something that really is game changing.
That's incredible. So, I mean, you're talking 80 to 100 million pounds of savings over a 6 or 7 year engagement for that manufacturer. We are getting ready to start wrapping down the next 4 minutes, but Alex, I want to, before we do that, let's spend 2 or 3 minutes. Let's talk about one of the other things that have come out of AMRC, and that is a guide for manufacturers to be able to implement MQTT Sparkplug as their framework. Can you talk to us a little bit about Factory X? Give us a understanding of where you can find it and how it could be used today for a manufacturer.
Sure. Yeah. So a few years ago, we set out to do a bit of research on, okay, if we were going to design a factory from scratch now, a modern manufacturing facility, what would that digital architecture look like? So just for a second, let's put aside all the legacy constraints and let's start with a blank canvas. And we did quite a bit of research, and we kind of came to the decision that MQTT and Sparkplug would be the technologies that we would recommend based on the various properties. I won't dive into that now. But both of those technologies really are, well, MQTT is very, very flexible,
right?
Very generic, very useful, but it's not very specific. Sparkplug is effectively a PDF document. It's a specification that says how to do something, or rather it says what to do, not how to do it. So we had these two specifications, and we kind of said, well, now what? What about all the other things that go around this if we were going to deploy this? So the work itself was funded with government funding. So the IP we've released into the public domain, and there's a URL on the screen there, or we can share this with you afterwards. But effectively, Factory Plus is a framework for how to deploy the kind of the baseline communication architecture within a manufacturing facility, and it uses MQTT and Sparkplug under the hood. But it doesn't just outline what they are. It looks at things like physical network topology. It looks at orchestration, containerization, data storage, data models, hundreds of other things as well. So the idea is it's really a start to finish manual for how to deploy this. And we've kind of approached it from two perspectives. We've got a blueprint, which is a really high level, abstract, these are the components, this is how they fit together approach. And then we've almost written a journal. So we use this now. We're kind of drinking our own champagne, as it were. We use this as an operational standard within the AMRC to collect data across all of our machines, and we use that for research purposes.
Right.
So as we deployed that, we kept that journal, and we call that the implementation guide. Step by step, install that server, connect those together, and run that command. And we explain it each step of the way. So the idea is the core framework, the blueprint is very high level, very abstract. But the implementation guide is very concrete, it's very low level, very specific to us. So neither on their own are massively useful, but the idea is between them you can interpolate and hopefully extract value for your application.
And you've made it publicly available at no charge. It's a great place if you want to grab some technology, start to advance your manufacturing and incorporate MQTT Sparkplug. Here's a place that you can start and have a plan to do so. So we thank you, Alex, and the team at AMRC for putting that together. That puts us in wrap-up mode. So the last 60 seconds, I know Pierre's going to drop with a hard stop. Alan, let's thank everybody and closing thoughts. Pierre, thank you for being here. Michael, thank you for being here. Sherry, appreciate you so much. Chris and the students, another shout out to Jeremiah, Robert, and Gideon. Thank you for what you've contributed. Can't wait to follow you in your careers and see where your big next steps are. Alex, always a thank you. Alan, closing thoughts?
So what has two butts and kills people?
I don't know, Alan.
An assassin.
Jeez. And with that, this rundown is in the books. Thank you, everybody. Have a great day. Alan, that was actually pretty funny.
Thank you.
Thank you all.
See you.